Okay, so it's 10 o'clock. Welcome everyone to the second installment of the ESA Junior Faculty webinar series. I show the ground rules, so we will have two talks on the general theme of public goods, on different aspects of public goods. And so we'll have 20-minute presentation followed by 5 minutes of discussion by the discussants and 5-minute Q&A. If you have questions, please use the Zoom Q&A section, and you can also vote. If you have the same questions and someone has asked, you can vote on it. And if we see pressing, clarifying questions, we will intervene and ask the question. There is an after party. So the seminar ends in an hour, and the after party using the same link would go on. So the presenters will stay after the webinar ends for the remaining questions. And what I encourage you to do is if the speaker did not get to address your question, please ask them again. What you can do is you can raise your virtual hand, and then we can promote you. We can unmute you, then you can talk. Okay. So without further ado, let's. I'm going to introduce our first speaker, Jing Yu. So Jing got her PhD in 2016 from the University of Munich, and she then worked as a data scientist at Didi Chuxing, which is the largest ride-sharing company in the world. And from 2019 until now, she has been a research fellow at the Beijing Institute of Technology. So she studies cooperation and coordination as well as contests. So I'm going to stop sharing. And so Jing, you're going to have the floor. So go ahead and share your screen.
So can everyone see my screen?
Yes.
Great. So I will switch off the screen because of the network. Okay. Thanks to the organizer, it's a pleasure to present here. Today I'm going to talk about one of my working papers joined with Martin Kocher, and the topic is leading by example in public goods games with benefit heterogeneity. So social dilemma is a kind of situation where there is a tension between individual and collective interest. All individuals would be better off from cooperating, but they usually fail to do so because of the conflicting interests. So how to promote cooperation in this situation has been widely examined in experimental economics literature. Some mechanisms such as punishment, reward, communication, and leadership have been found to be effective to some extent. Leading by example is actually one type of leadership, which means that some first mover sets example which will induce or inspire others to follow. This is very common in the workplace, where the leader of a team puts a lot of effort into work and therefore inspire the employee in his or her group to work hard too. Also think about the global cooperation to fight against climate change. The unilateral emission reduction by some country is also a case of leading by example. However, no matter in the teamwork or in the global cooperation, it is very likely that some people or some country are they gain higher benefit from cooperation, while some others is more likely to gain lower benefit from cooperation. So our research question is that under this benefit heterogeneity, will leading by example work in promoting cooperation? And in this case, who will make a good leader? So in homogeneous populations, there is a mixed evidence on the effect of leading by example. Some studies find that leading by example can promote cooperation levels significantly, while some others do not find such a significant effect. However, almost all of them have found a positive correlation between leaders' contributions and followers' contributions. regarding benefit heterogeneity, the previous literature has found that there is a tension between high and low benefit members in terms of the contribution fairness. So for the high benefit members, they usually would like everyone to contribute similarly. But for the low benefit members, they tend to believe that high benefit members should contribute more because they benefit more from cooperation. They believe that all members' payoff should be similar after contributing. So in this heterogeneous population, punishment or reward are found to have very little effect or have no effect, while the effect of communication is also reduced. So this paper actually combines leading by example and benefit heterogeneity. Now let's come to the experiment design. Our experiment setting is a time-period linear public goods game. A group consists of 4 persons. In each period, each group member gets endowment of 20 tokens, from which they can decide how many to contribute to the public good. The marginal benefit from the cooperation varies among the 4 members. So there are 2 high benefit members whose marginal benefit from the cooperation is relatively high. Here the parameter is 0.8, and 2 others are low benefit members whose marginal benefit is relatively lower, and the parameter is 0.4. So in our setting, leading by example means that some first mover, some leader, he or she make his or her contribution first, and other members make their contribution decisions simultaneously after seeing the first mover's contribution decision. In contrast, the no leadership means that there is no leader at all, so all 4 members contribute simultaneously to the public goods. Our experiment consists of 2 parts. The first part is the repeated public goods game I just talked about. There are 4 treatments. The first is the baseline treatment, in which there is no leaders. So all 4 players contribute simultaneously and independently to the public goods. There are 2 exogenous leadership treatments. One of them is high benefit leadership, which means that in each period, the leader is randomly selected from the 2 high benefit players. Well, in the other treatment is low benefit leadership, which means that in each period, the leader is randomly selected from the 2 low benefit players. So the difference between the 2 treatments is that the leaders has different benefit type. In addition, we also implement endogenous leadership treatment, which means that in each period, we do not impose leaders anymore, but rather we let players choose whether they want to be the leader. If no player chooses to be the leader, then all 4 players contribute simultaneously, just like in the baseline. If more than 1 member choose to be the leader, then the actual leader is randomly selected from the volunteers. So after they have made their contribution decisions, we ask each player to estimate about the contribution level of their group members, each of the group members, but separately for each benefit type. And after this process, they can get to see the feedback in that period, including benefit types, contributions, and earnings of each other group member. If there is a leader in the group, they can also get to see the identity of the leader. So after part 1, subjects get into part 2. Part 2 is a social value orientation test. We use the test initiated by Librand. In this test, all players need to choose payoff distribution between themselves and another anonymous subject in the session. So the purpose of this part is to get each player's cooperation attitude. The experiment was conducted in the laboratory of University of Munich. For the baseline and for each of the exogenous leadership treatment, we have about 12 independent observations. For the endogenous leadership treatment, we have 24 independent observations. Now let's come to the results. First, let's see the treatment effects. First, we use the non-parametric statistics to see the treatment difference. The left-hand side of the figure here shows contribution dynamics of the 4 treatments. So the baseline is the blue line shown here. Over all time periods, we do not see any significant difference between any 2 of the 4 treatments. We only see there is a statistically significant slower declining trend when leaders are high benefit and randomly imposed as indicated here.
Excuse me, Jing. So let's intervene with 2 questions from the Q&A site. Natalie asks, do the followers know the type, i.e. the benefit of the leader before making their contribution decision? So
yes.
People voted
yes.
on this question, so they do know.
Yes, they do know.
Okay, and then Boon Han asked, before talking about the results, would you be able to shed some light on your theoretical predictions and hypotheses? I mean, feel free to postpone this, but if you can just talk a little bit about it, that would be good.
We do not have the theoretical predictions because if we assume that all peoples are completely selfish and risk neutral, then the contributions in all the treatments are all 0. And in the endogenous leadership treatment, people will be indifferent being the leader or not.
Okay, yeah. So that's the sort of the Stark benchmark. Go ahead. Good. Let's move. Yeah. Okay.
So it is quite surprising. It is quite surprising that there is not significant enhanced effect in the endogenous leadership treatment. So we better look at the 3 final states in that treatment as shown on the right-hand side here. Well, what we find is that contributions with voluntary leaders are significantly higher than those in the baseline. However, there is another case in this treatment where there is no voluntary leader at all. So in this case, contributions are pretty low, are significantly lower than those in the baseline. And this negative effect offset the positive effect brought by voluntary leaders. So in this treatment, contributions are highest with the voluntary low benefit leaders and are lowest with no voluntary leaders. We also run a regression analysis on the individual level, controlling for players' cooperation attitude in part 2. So after controlling for cooperation attitudes and the time trend, the results are basically similar as before, except that we now see a marginally significant increase in the endogenous leadership treatment, but the magnitude is still quite small. So if we focus on the last 5 periods, leadership seems to be more effective. However, the positive effect brought by voluntary leaders, they do not change much, even if we control for the cooperation attitudes. This figure shows the frequency of the 3 final states in the endogenous leadership treatment. And so overall time periods, leadership happens in about 74% of the time, about 2/3 of which are voluntary high benefit leadership, the blue one, the blue color. So the voluntary high benefit leadership, the frequency of it is quite stable. It's relatively stable over time. It's about 45%. Well, the frequency of the voluntary low benefit leadership, it decreases significantly over time, and we think this is another large effect in the time separately for each benefit type. What we find is the low benefit members, their willingness to volunteer is much lower, is significantly lower than that of the high benefit members, and the willingness also decreased significantly over time. And we'll talk about the possible reasons for this later on. Okay, now comes to the leaders' behavior. We compare leaders with their counterparts with their same type members in the baseline. So the left-hand side is for high benefit members and high benefit leaders. So as compared to their counterparts in the baseline, high benefit leaders, their contributions are relatively stable. And their contributions are also significantly higher than their counterparts, especially for those voluntary high benefit leaders. For the right-hand side is for the low benefit. Also see a significant increase compared to the counterparts of the baseline. Things are a bit different for the voluntary low benefit leaders. Voluntary low benefit leaders, their contributions are relatively stable, and their contributions are also pretty high. So the contributions are significantly higher than the counterparts of the baseline in almost every period, and also significantly higher than their than the randomly imposed leader. So in general, leaders, they set good examples to some extent, especially for those voluntary leaders. How about followers' behavior? Well, they increase their contributions because of leaders' examples. We run this regression to compare followers' contributions relative to their counterparts of the baseline. What we find is there is a significant increase in low benefit followers' contributions when leaders are low benefit and voluntary. Because before we know that in this case, leaders, they contribute quite high and stably. But we still do not see an increase in the high benefit followers' contributions. And other coefficients in this regression are also positive but not significant, which means that leaders' examples have limited effect in promoting followers' contributions. So we further compare the distance between leaders and followers' average contributions and find that this distance is actually higher with voluntary leaders, which means that followers exploit voluntary leaders more strongly than relative to the randomly imposed leaders. So how do followers reciprocate to the leader? Well, this reciprocity depends on leaders type and followers type. We run this regression to identify the effect. So when followers are high benefit in the two cases, we find that low benefit followers, they reciprocate to the leader much less than high benefit followers. However, when the leaders are low benefit, we do not see any significant difference in reciprocity between the two kinds of followers, which means that for those different type followers, that is, for those followers whose benefit type is different from the leader, their reciprocity are basically according to their own perception of contributing fairness, which we think is one of the reasons why we do not see large effect of leading by example here. So given leaders' behavior and followers' behavior, this figure shows the payoff dynamics of leaders and followers in each case. And this figure can help us understand better the low benefit leaders' behavior. So for those randomly imposed leaders here, as we remember, they contribute relatively high at the beginning, making the earnings the lowest within the group. So they decrease their contributions very quickly and do some makeup. For the voluntary low benefit leaders, they not only need to bear the lowest income within the group, but they also need to bear the very large within group inequality. So we think this is possible. This perhaps can explain why we see a decreasing trend for low benefit members to volunteer over time. Another interesting finding in our paper is is when leaders are randomly imposed and from the high benefit members, there is a path dependency in group contributions, as shown in the left, as shown on the left-hand side here, which means that group contribution in period 1 correlate with group contributions in later periods significantly and positively. And on the other hand, group contribution in period 1 also correlate with leader contribution in period 1. So this implies that it is partly in the hand of the initial leader determining the group contributions in the long periods. And this is also confirmed in the analysis of group heterogeneity in this treatment. In this treatment, we basically classify groups into two types according to the median value of the average group contributions over all time periods. So those groups with contributions higher than the median value, we denote them as successful groups here. We find that in successful groups, leaders contribute significantly more than leaders in other groups ever since the first period. So consequently, followers and the whole group's contribution also enhanced significantly from the beginning. So what kind of leader make high initial contributions? We find that leaders' initial contributions correlate with their initial beliefs towards their same type followers' contributions. So we separate out those groups whose initial leaders have higher beliefs, have high enough beliefs about the same type members, and find contributions in those groups are significantly higher than those in the baseline. So this result implies that under benefit heterogeneity, randomly selecting leaders leading by example is insufficient to promote cooperation. If imposing leaders, we better select those high benefit members who are optimistic about the same type members' cooperation level. Okay, now comes to the summary of this study. So we basically find that under benefit heterogeneity, leading by example by either randomly imposed or voluntary leaders has limited effect in promoting cooperation. The reasons are several respects. So if we randomly select leaders, we cannot guarantee that the leader will set good example. For example, if the leader is pessimistic, especially the initial leader, if he or she is pessimistic about others' cooperation, then he or she will set bad examples. If we do not randomly impose leaders, but we let players, we let people to volunteer, we cannot guarantee that there is always a leader. If there isn't any voluntary leader, then contributions will be negatively influenced to a large extent. Followers' insufficient reciprocity is also blamed, especially when leaders are voluntary. However, there is also bright side. The bright side is that under benefit heterogeneity, appropriately selecting those optimistic high benefit members as the initial leader has the potential to increase the cooperation level of the whole group. And that's all of my talk. Thank you very much.
All right, thank you, Jane. So Marie-Claire is the discussant. Marie-Claire, do you have slides?
We have slides, yes.
Okay, yeah. So there's a green button at the bottom which says share screen. If you do, then we'll see your screen.
Can you see them?
Yeah, perfect.
Okay,
thank you.
So, hi everyone. Thank you, Jing, for your excellent presentation. So I really enjoyed reading the paper that I found very, very interesting because it addresses two great topics, leadership and heterogeneity, and it studies them in combination, which is the original part of the contribution. Of course, we need to know more about what makes a good leader and how is it possible to convince others to follow you just through your example. And heterogeneity is also important in social dilemma because we want to know more how to deal with the conflict between efficiency and equality when heterogeneity is introduced in a public good setting. And indeed, we may have two types of normative conflicts. One is because people hold different views about what makes an outcome fair. Or people don't conflict, but there are multiple rules, multiple possible rules, and they just need some help to coordinate on the same one. And so the question is, does introducing a leader in such a setting help solve the normative conflict? So I think it's a very important question. And now I have, of course, myself a number of questions about your paper. The first one is related to hypotheses. So of course, the standard hypotheses are very clear, as you reminded them earlier. But it would be probably interesting to say more in the paper about why you expect that introducing a leader would make a difference. And so the question is, why would introducing a leader solve the conflict between efficiency and equality in such a setting? We know that leaders may increase efficiency when groups are homogeneous, but it's not always the case. And we also know that standard mechanisms like communication or sanctions are much less effective in heterogeneous groups compared to homogeneous groups. And indeed, heterogeneity implies that there are several possible rules or several possible norms of contribution. So for example, you may have a norm, an efficiency norm. You want to maximize efficiency in the group. In that case, you need to convince everyone to fully contribute the whole endowment. But in that case, you also maximize inequality between people. Alternatively, you could follow another norm that is equalizing earnings. And in that case, you need to convince the group members to contribute very differently. So the high type should contribute 4 times more than the low type. And you can think of other norms such as proportionality, for example. And so it would be important in your design, sorry, in your paper, to explicit how could a leader facilitate coordination on one or another norm? Because in your setting, the high type leader that fully contributes cannot signal anything. I mean, he cannot signal which norm he would like to support. Only the low type people can signal their favorite norm by contributing either 20 if they want to promote efficiency, or 5 if they want to promote equality. But in that case, it's very difficult because it's a very noisy signal. Because if I contribute 5 as a low type leader, you don't know whether it's because I want to promote equality of earnings or if I am just a free rider. And so it's a very noisy signal. Now, regarding self-selection, it would be also important to be more specific about your hypothesis, to tell us exactly why you expect that, or should we expect that there are more volunteers or less volunteers than in a homogeneous setting? Would leaders have different motivations? Do they need different motivations to lead in a heterogeneous setting compared to homogeneous settings? And it would be good also to have an hypothesis about why we should expect that self-selected leaders are more effective or less effective compared to homogeneous setting. And if the expectation is that they are less effective, why not in that case introducing a mechanism that would try to improve their efficiency? For example, letting them communicate with group members. I try to be brief. I have a few questions about the design and the treatment. The first is about self-selection treatment, because compared to the 2 other treatments, you have here 2 differences. The first is volunteering, and the second difference is that each type can contribute, can lead. So to some extent, a treatment is missing where each of the 4 members can be randomly selected as a leader, or a treatment in which only high types or only low types could self-select with some possibilities of taking turn, for example. So this could be a suggestion for another treatment. Personally, I think I would have added a control treatment with homogeneous groups so that you could compare the specificity of heterogeneous setting and in particular conduct some diff-in-diff analysis. And in terms of extensions, I think it would be interesting to endow a leader with instruments, I think of communication, or to let people vote on the basis of a leader candidate's platform to identify the preferred norm in the group. So finally, I have questions about the data analysis. First, I would like to know if you could tell us how many groups coordinate or seem to try to coordinate on the equality norm, on the efficiency norm, on the proportionality norm, and whether some leaders try to implement one of these norms. Second, in the paper, you don't say much about the subject's beliefs about others' contributions. So you say something in your talk. I think you have very rich data on beliefs, so it would be interesting to exploit them more. I was surprised with the number of low-type subjects volunteering as leaders, especially at the beginning of the game. I think it's, of course, there are less low-type volunteers than high-type, but still many are volunteering, although they will earn less for sure. So it would be interesting to explore more their motives to lead and to stay candidates throughout the session. I have questions also about the highest group contributions with voluntary low-benefit leaders. It's your third result. To me, it doesn't mean that they have more influence, but it means that the situation occurs more frequently at the beginning of the game, so before the decay of contributions. And so in the paper, there was no time trend included in tables 4 to 6. And of course, it would be important to control for time because of this decay in contribution over time. Finally, and I would stop there, how many volunteers are there on average in each group or in the groups? Do groups with more volunteers succeed more? Do rejected leaders, because you can have only one leader in a group, so some volunteers are not able to lead, do they change their behavior after being rejected to some extent? Do you see some people who try to take turn in the group to alternate the cost of being a leader, etc.? And of course, I have a number of other questions, but I think that my time is out, so I will stop here. Thank you.
Yeah, thanks very much.
Thanks. We do have questions, but we are also running a bit short. So I would suggest that we move to the second talk, and then we leave all the questions at the end. So Ted will introduce our second speaker.
Yes, I'm very happy to introduce our second speaker, Prithvijit Mukherjee. Prithvijit is currently a postdoc at Utah State at the Center for Growth and Opportunity, having finished his PhD from Georgia State last year. He's interested primarily in social and economic networks. He has a paper on cost sharing goals in public goods games, so you know Yan and I are going to love that. But today he's going to talk to us about, can we talk our way to equity and efficiency? Prithvijit, please carry on.
You're muted.
Can you see my screen?
We can hear you now, at least. We can't see your screen yet.
That's weird.
Yeah, so go to the green share screen button. Yeah.
There we go.
Perfect.
Good.
Thank you so much for organizing this conference, and thank you, David, for agreeing to be a discussant on my paper. Today, we're going to be talking about communication structures in games in networks. So one of the features of strategic interactions on network is the local nature of the information. The local nature of the information can impede coordination among different components of the network. So one evidence is the low coordination of groups onto the Nash equilibrium profile, which is seen throughout the literature on experimental literature on networks. The other thing which the local nature of interaction can do is that individuals are not completely aware of the full implications of their actions because they're taking this action locally, but different components of the network interact with each other in these strategic settings, which determines equilibria. So these could have long-term consequences. For example, Katz et al. Show theoretically that if groups are separated enough, you can have persistence of inequalities across generations. One such example of inequality, which I'm very well aware of, is the caste system in India. So Munshi and Rosenweig in the 2018 paper tried to look at provision of local public goods. What they find is that there's huge underprovision of local public goods. There is very high cooperation between intra-group, but inter-group, there's very low cooperation. And people who are on the periphery, which are the lower caste, end up paying the cost for it. Another paper, Banerjee and Somanathan finds that when you have an increase in social fragmentation, it leads to a lower provision of the public good. So also, this kind of in-group, out-group problems can be thought of as homophily, and there's a literature which talks about how homophily could affect learning on networks and other factors. So even in artifactual field experiments, just knowing that there are people from different social groups can lower cooperation. So what I'm going to be talking about today, I would like to just go through an example so people can gauge a better understanding of it. So there are three farmers, let's assume, and they're arranged on a line. So farmer A can see what farmer B does, and B can see what C does, and but A and C can't observe what each of them are doing. So let's think of a scenario where every period they're thinking whether they want to invest their time and energy to learn about a new production technique, or not do that and learn from their neighbors, and save the time and energy and benefit from free riding. So there are two equilibriums in this setting. The first one is where B invest and A and C are not investing. So this could be socially efficient because there is one investment and two people are getting the benefit from the public good. The second pure strategy equilibrium would be where A and C are investing and B is not. And this is the one we are empirically more likely to observe. Like the literature, Chanist in the 2018 paper find that the second equilibrium, which is stochastically stable, determines a lot of the equilibrium selection. So the question is, how do we make groups to improve both on equity and efficiency in a repeated game setup? So in this case, communication can be very crucial. It's been shown it's been widely documented in the networks literature that communication as information is an important source of power, and different information communication structures could lead to different coordination on different equilibria, which could influence how the total surplus is divided among people in the network. So for example, if you let everyone in the group talk, they can choose across rounds to alternate between these two equilibria, which would improve both equity and efficiency. Or if you let only the neighbors talk, that A can talk to B and B can talk to C, and only neighbors can talk. This might be effective in larger groups, but this only reinforces the underlying asymmetries which is introduced by the network structure in which they share externalities. So the research objective for this paper is to find a link between the two communication structures, global, where everyone can communicate, which has been widely studied in the social dilemmas literature. The second one, which is local, where only neighbors can communicate, on equity and efficiency in a public goods game. So basically, the contribution of the paper is to look at not only the heterogeneity in the communication structure, which has been the focus of communication games and networks, but also introduce an underlying asymmetries in the sharing, in the space for externalities, how externalities are shared between group members. Broadly, my results have done in two parts. So one is equilibrium coordination, which I will be talking about a lot about today. And the second thing is about coordination, which I mentioned that this not having communication might make coordination really hard, and I'll go through that. I will not be talking about it, but I'm happy to discuss later in the Q&A session. So looking at the game, so agents simultaneously decide whether to invest or not. Each person gets a benefit of B. If she has access to the public good, the cost of provision is strictly less than B. So in this example, B and C are investing, so A gets the benefit from B, but note that E is not investing and D is not investing. So since none of them are investing in the local public good, E ends up getting 0 for the round, but C gets a benefit from C's investment, D gets a benefit from C's investment. So you can see how the local structures of interactions kind of play out in this kind of a game, in this kind of a best shot public good game. So what Nash equilibrium, let's consider this equilibrium where B and E are investing. The best response requires neighbors to invest when nobody else is investing and not invest when at least one of your neighbors is investing. So you can see that B has to coordinate actions with A and C. And this could lead to local, simply local coordination failures. Whereas Nash requires people who are not even connected to each other and don't see each other's actions to positively coordinate the action. So A, C, and D need to not invest for B and E to invest, and that to be a Nash equilibrium. So you can see that coordination in absence of not, there's no surprise why you find very low levels of equilibrium coordination in games, because it's a fairly complex structures and coordination requires coordinating on the equilibrium requires coordination among people who are not connected to each other. So I just wanted to spend a minute talking about why I select these three network structures. So if you note that across all the three network structures, we have the same efficient equilibria in which there are two people investing. So all these three network structures are very comparable. The second factor is the inefficient equilibria in both line and asymmetric is the same. So which allows me to study a simple question is that what happens when you, what's the value of adding a link? So you can go from line to asymmetric, but just drawing a line between B and D. And you can go from line to a circle by drawing a line, a link between A and E. So I wanted to figure out what happens, what's the effect of just adding a link. We'll note that adding a link between line and asymmetry just increase the heterogeneity in the number of neighbors people have in the experiment. And secondly, having 5 people is enough to see that there are coordination between people who are further away from each other. They can't directly communicate, so the two communication structures might play a very interesting role. So communication in this case is cheap talk. It's non-binding. It's payoff irrelevant. So how I implement the communication is like a group. It's like a Twitter or a Facebook wall. So in global, everyone can see each other's Twitter feed or Facebook wall. In local, you can only see what your neighbors are typing on their walls. So it's not private communication. It's public communication, and so that's one of the features. So we're not doing personal emails to people. So a bit about the experiment design. There are 180 subjects which participated in 12 sessions, and each session consisted of 3 stages of a round. So basically it was repeated for 10 rounds, and within each stage, the position and the group was fixed. So you get to know your group members. So if there are any repeated game strategies, it gives them space to come up with that. Across sessions, we varied the network structures. subject only saw one of the three network structures. They did not interact with all the three network structures in the experiment. Across the sessions, there were three treatments which I ran. The baseline is without any communication, where the benefit was $1 and the cost of provision was fairly high. It was about 75 cents. And in global, you could communicate with other group members for a minute before you make a decision. And in local, only neighbors could communicate. So just have a look at the screen. So in this case, C can talk to everyone in the group, and I urge them to talk only about their investment decision and who in the group should invest. So to kind of bar out any, so this is free form communication. So just to bar out any random chat which they could come up. And most of the chat data looks like text messages, very short and precise about these. And the second one is, which is the local communication, where basically C can only see B and D's chat Twitter feed, if you want to think about that. So going on to results, what I find is that as compared to the baseline, the efficiency is much higher in global and local. It doesn't matter which communication structure you introduce. What's surprising is when I went in to do this experiment, I thought global would work really well, and local maybe not, because it reinforces the asymmetries in the network through the communication structure. And you find surprisingly that both local and global does well with, and these differences are not statistically different from one another in terms of overall efficiency. And also note that if what has been observed in the literature, that in line and asymmetric, if groups always coordinated on the inefficient equilibria, then the efficiency would have been 0.78. And we have efficiency which is higher than 0.78. So just another graph saying, just looking at the time trends. So they start about the same point and across the three treatments, and then they deviate pretty significantly across the rounds. And if you're looking at equity, the Lorentz curve is basically showing that as compared to the baseline, which is the blue lines here, I'm not sure if it's clear, communication increases the equity of provision. So one way people could coordinate on more equitable actions is by coordinating on different equilibriums which promotes both equity and efficiency. So I'll just look at some of the equilibrium provisions, coordination. So in the baseline, only 17% of observations are consistent with an equilibrium prediction. But you can see with once you introduce the two communication treatments, the coordination on equilibria increases substantially. And in fact, in asymmetric, subjects figure out a behavioral equilibria where they stick around for a while, in which B and D are investing, which is surprising because they haven't actually been in the line equilibrium to see that equilibria work out, but they come up on their own through their chats, and they do it pretty consistently in the global treatment. So of course, this is a repeated game. I just have a couple of repeated game strategies which can promote both equity and efficiency. So the first one, which is about equity, where people are taking turns in which A, C, and E are investing once, and in the other round, B and D are investing. I show in the paper these would be Nash enforceable by a simple Grimm's trigger strategy, and doesn't really matter on the length of the play as long as they agree to this strategy. The other thing which groups could do, there's literature and experiments where like groups have taste for efficiency. So they could alternate between the two efficient equilibriums. But in this case, it's not really equitable because C never invests and gets a lot of benefit and continues to get benefit from the public good. So just keep these in mind while I discuss the results for the equilibrium selection. So in global, 83% of the groups successfully coordinate between A, C, and E investing ones and B and D investing. So what I have below is just the Markov transition probabilities. So if you start at L1, there's a 94% probability that you'll go to L2. And if you start at L2, there's a 77% probability that they're growing at L1, going back to L1. So this is not random behavior. They're doing it consistently across rounds. About 93% of all the observations which are consistent with an equilibrium are basically focused on these two, alternating between these two strategies. In the local, you find a similar trend. You find that people are alternating between AC and E investing once, and B and D investing in the other round. But you also find there were two groups which were consistently alternating between the two efficient equilibria. So the groups, so this is very group dependent. So if groups have taste for efficiency, they would figure out a way of alternating between the two efficient equilibrium profiles. And you can see these similar patterns in the Markov transition probabilities. Do you have questions so far? No? So in the asymmetric network, the one which I can show theoretically improves equity is alternating between all the three equilibrium profiles. What we observe empirically is groups are consistently alternating between A, C, and E investing and B and D investing. Again, B and D investing is not a Nash equilibrium because B can stop investing anytime because one of his neighbors is investing D. And again, if groups value efficiency, they can coordinate between A2 and A3, which is B and E are investing once and A and D are investing. Again, this is not Nash enforceable, it's just purely if they have taste for efficiency, they might do this kind of a switch. So in global, about 18% of the decisions are consistent with the behavioral equilibrium, which I find, which is consistent, which is where B and D are investing. About 1/3 of the groups consistently alternate between A, C, and investing once, and B and D investing. So there's a 50% chance that each of, there's a 50% chance that each of, across the rounds, people are investing, each group member. And across the two, there are two groups which alternate between the two efficient profiles, and there's one group which actually rotates through all the three Nash equilibrium profiles across rounds. In local, you find that the number of people who are actually coordinating on ACE investing and BND falls dramatically. And that shows how different structures of communication can affect profiles people can coordinate on. But you can also see that what changes is groups value overall efficiency. So people who are central, like B and D in this network, who have three neighbors, tend to participate, tend to invest more and more. So they are coordinating, they're more likely to coordinate on equilibriums where B and E are investing on, or A and D are investing. So circle is again, it's a symmetric it's a symmetric network. So all the equilibrium profiles we have are efficient. And it also has the largest share of, it has the largest set of pure strategy Nash equilibria, which is reflected in global. When there are many people talking, it makes it really hard for people to coordinate and also to alternate on a set of equilibrium. Only half of the groups are actually successful in coordinating or even having any patterns. And this is all over the map, the coordination patterns. Global, once we move to local, where there are only two people, when you're only talking to two people and not everyone in the group, it leads to higher levels of coordination. It also increases the number of predictions which are consistent with a Nash equilibrium. And again, there are no set patterns. And again, theoretically, we won't have expected a set series of pattern because there is nothing to anchor your equilibrium strategies with. And so that's the results for circles. So one of the key results in the literature is looking about looking at speciality and the likelihood of investment. And what we find is,
if I can nudge you, you're about up at the end of your time here.
Okay, I'm on my last slide.
Yes, thank you, good.
So so basically what we find is that what can incentivize people who are more central to invest? What we find is essentially that with communication, in the baseline, you have a negative relationship between the number of neighbors you have and your likelihood of contributing. But with local and global, you find people who have more neighbors are contributing more. So you're kind of getting, if there's a strategy to incentivize people who are central to invest, communication might be a way to do it. So in conclusion, in absence of communication, what we find is adding a link increases efficiency. So going from line to either asymmetric or circle gives you an increased efficiency. So it's not bad to have more asymmetry. However, we do find a negative relationship between the number of neighbors and the likelihood of making an investment. Communication improves both equity and efficiency. You find line to be very successful in coordinating on equilibrium profiles, and equilibrium gravitates towards strategies which generate equitable outcome for all group members. In asymmetric, in absence of such equitable strategies, people actually come up with their own action sets which promote these simple equitable strategies. We also find that a larger equilibrium set leads to frequent miscoordination in the circle network, and groups fail to generate any consistent pattern of behavior. Thank you.
Good. Thank you. All right, so over to our discussant, David Cooper.
Hi, you have to turn off your share screen so I can, okay, am I able to share screen now? Yeah, good. There we go. Okay. And I apologize for any odd noises. To get a decent internet signal, I have to drive to the local school and sit by the cell phone tower. So you probably hear my engine running. Anyways, thank you for giving me the opportunity to read your paper, Dr. Mukherjee, and I enjoyed reading it. Why is this not advancing? There we go. So first, just beyond getting into any comments, and I'll try to keep this short because I know we're getting late. The first question is, why is this an interesting paper? And there are a bunch of things that I think are actually interesting about this. There's no shortage of experimental papers or theory papers, for that matter, about playing games where players are linked through a network. And there's no shortage of papers about combination. But the number of papers, it's not zero, but the number of papers that combine these two topics is actually relatively small. And what makes this paper interesting is two things. So we have this tendency to always study the same few games, but there's some interesting games that don't get studied much. And the Best Shot game is actually a very interesting game. It has a long history and experimental. It has some economic relevance, and it doesn't get studied a whole lot. And there are a couple of things that make it an interesting game to look at. The first is that most of the studies of communication networks look at strategic complements. This is a case where you have strategic substitutes, and that distinction is important and relevant for understanding how communication is going to behave. The other thing, the nature of both the networks and the equilibrium means you're going to have a lot of asymmetry. And we know rather less about what happens with communication when you have asymmetric outcomes than when you have symmetric outcomes. So in particular, the Best Shot games are, when they're on a network, these are really very complicated coordination games. At this point in time, we know a fairly large amount about how communication affects behavior in symmetric coordination games. And for the most part, the result is that communication helps you reach efficient coordination. We know much, much less about what communication does in asymmetric games. And one of the, it's a very basic result, but it's a nice result. These are very asymmetric games. And what you see is that either communication structure is improving efficiency, and that's a nice result because it's not obvious that that has to happen. There's the famous Cooper et al., different Cooper et al. Study from at least 20 years ago looking at Battle of the Sexes where communication had very ambiguous results. This is a very clear result that it is in fact increasing efficiency. Another nice thing is that you can say something about how it's doing that. And in this particular case, the effect is clearly coming through greater access, that it is more likely that you will either yourself or have a neighbor who's providing the public good, Because the worst thing here for efficiency is to be in a situation where there's miscoordination and there are people who end up doing it without the public good. It's interesting that it doesn't seem to matter much what type of communication is used. That's a little bit surprising. And that the result is strong regardless of network type. It's not the same regardless of network type, but it's a very strong effect regardless of network type. And that's a bit surprising as well. One thing that particularly surprised me is that intertemporal rotation is quite common, so that they're not just playing a single stage game equilibrium over and over again. They quite commonly are rotating between different equilibria, which has the effect of making things more equitable. That's a fairly complicated thing to coordinate. I was a little surprised to see that, and it's quite interesting that that comes out strongly in the data. Something that you didn't emphasize very much, and I actually think is quite important, is that communication changes the adjustment dynamic. So there's this focus in much of the literature on SSE, stochastically stable equilibrium, and without communication, that sort of makes sense. That's the whole idea there is you're looking at the steady state for an equilibrium where you basically best respond to what happened, naively best respond to what happened in the last period with a little bit of noise. That makes sense if that's what the dynamic actually looks like, and it does without the leaders, without communication. But once you add communication, the dynamic actually changes quite a bit. And, sorry, whoops, I just lost my window. That's what I get for flipping a little too fast. All right, let's try this again. Sorry about this. There we go. There we go. So this figure was one that you didn't talk about much during your talk. And what you're seeing, particularly what I'm interested in is the part that's on the right. This is the myopic best response. These are people who are just best responding to what happened last period. And you can see that if you look, it doesn't matter what the network structure is, although it's strongest in the line. If you compare the baseline with the two communication treatments, you always see a lot more of this myopic best response when they can't communicate. So it suggests that you're altering the dynamic by adding communication. And I found that quite interesting because it suggests something about what the long run resting point is going to be and what you can or cannot say about equilibrium selection. Because if you're going to make predictions that rely on a particular dynamic, it turns out that that dynamic is sensitive to whether or not communication is present. And I thought that was kind of interesting. So finally, or maybe not finally, oh, I lost some of my stuff. Oh, well, I can do it from memory. Maybe, there we go. So some things to work on. I think the most important thing to work on here is there's no material in the paper on the content of what people said, and the content could be quite interesting. Chat content is really cheap process data. There's lots of interest in process data right now, and you get a lot of insight into both what people are thinking and the process by which groups reach agreements by looking at how they communicate and what they talk about. And a couple of things that I think are low-hanging fruit in your paper and worth talking about are what differentiates successful and unsuccessful groups. And you look a lot at aggregates, but there's a lot of variation in terms of what groups do and how they do. And looking at what they say might give you some insight into what successful versus unsuccessful groups are doing. Something that was surprising was that the communication structure didn't matter. Looking into what they say might give you some insight into why that communication structure just isn't mattering. As I read through the paper, and this is more about the paper than the presentation, the description of the theory was unclear. And in particular, this idea of SSE has been important in the literature. You talk about it some within the paper, just introducing the idea, but it kind of disappears when you get to the results section. And that was there today as well. And I actually think that the results of your paper have something to say about this. And I would have liked you to sort of think more about the theory and link it more with the results. In particular, think more about stochastic So stochastically stable equilibrium, what it says about the underlying dynamics, and what you're observing in terms of dynamics within your data. That in the data analysis, once again, this isn't something you stress so much in the talk today, but you do have to be careful. There's this design issue that's giving you trouble. That's the way the design is set up, is that you go through all 3 treatments. You're in a randomly formed group for the first treatment, which is always baseline. You go through the 2 communication treatments in a random order. When you go through those 2 treatments, your group is changing. You're randomly drawing a new group. And what that means is that you're losing independence as you rematch the groups. And when I look at your statistical analysis, you have a lot of regressions where you're using random effects, where the random effect is at the level of an individual within a group. But the moment you remix the groups, you're losing independence between different groups that are in the same session. And even if you're going to use random effects, they pretty much have to be at the group level than the individual level, because the people within a group are interacting. And you need to go back and look carefully at those regressions and make certain you're not making unwarranted assumptions about what's an independent observation. And as a more general question, and you could kind of see it in today's talk, because you didn't talk about the regressions at all. I was looking at this and saying, why are you running regressions in the first place? What is it that you need to control for that you need these regressions? That it seems like most of what you wanted to look at simple non-parametric tests would have done just fine, and would have been much easier to resolve these independence issues with simple non-parametric tests. I like regressions, I use them frequently, but they're not always the best answer. And I was wondering if maybe you really needed all those regressions that you had. And finally, I did worry about order effects in your data. The most interesting results revolve around comparing the baseline treatment with the 2 communication treatments, but you always had the baseline treatment before the 2 communication treatments, and these are complex games. What that implies is that you may have trouble separating what are learning effects, people figuring out how to play in this complex environment, versus what's an actual effect of the communication. And I would have liked to have seen you do more to try to sort out the order effects. And I apologize for rattling on, but I pass it back to Ted.
All right, yes. Thank you, David. And yes, we are after the top of the hour. So of course, we do have the after party, and everybody is encouraged to stay and to continue the discussion. But before that, just in case everybody does leave, I wanted to thank Jing and Prithvijit for speaking, Marie Claire and David for their very thorough discussing. All right, and thank, as always, all the attendees for joining us. So see you once again, same time next week. And meanwhile, enjoy the after party.
Thanks, everyone. Let me just chat a little bit about the process issue. So if you have a question, there's an option to raise your hand. So you raise your virtual hand and we'll unmute you. It's kind of, I wish this process doesn't have to have such a hierarchical way of organizing it. Okay, so Mengxing, you have a question. You can talk. I asked you if you unmute yourself. Okay.
Hi, Professor Chen. Can you hear me?
Yes, I can. Yeah.
Oh, okay. I have a question for Jing.
Go ahead. Yeah.
Yeah. A very nice paper, and I'm just curious about the belief difference between the 2 different types of the high benefit type and the low benefit type. For example, if the low benefit type always expects a higher contribution level from the high benefit type. Yeah, that's all. Thank you.
Yes, exactly. Low benefit members, their beliefs about the contributions of high benefit members are actually higher than the beliefs about the other low benefit members' contributions. So it's like their beliefs quite match the contribution difference between the 2 types. So do I get what you ask?
Yes, yes. Oh,
yeah.
yeah, okay. Yeah, thank you.
So I see in the Q&A there are two questions on, one is by Boom. Do you see a lot of message relaying in local communication, i.e. B tells A, C what A says, etc.? So this is for Prithvijit.
So, all fairness, I haven't really analyzed the message data really carefully, but what you're getting at is at the right hypothesis. So if this is kind of a communication game which was talked about by Meyerson, since these are all connected networks, so that's how local could improve efficiency, is just by people can form collations and share information amongst them. So you do see, so that's the way I would expect theoretically this to work out as an explanation for why these two can be equivalent. But I haven't analyzed that data, so.
Yeah. So Stephanie Hager also had asked a question in the Q&A, which is, so she has a clarification question. I'm not sure if Stephanie is still there. Stephanie, do you want to ask the question yourself, or?
Yes, can you hear me?
Yeah.
Okay. No, it was about the first result in Prithvijit's paper with the bar chart. I was just wondering, it was an average result. So I was just wondering, really quick clarification, whether it was an average across the 10 rounds of play?
Yes.
Okay. And then I know that after that you had sort of an evolution of how it changed over the different rounds, I think. But I'm just wondering, thinking about learning that may have happened throughout the game.
So essentially, if I did check for at least for the first couple of rounds, there are no statistical differences between the efficiency across the three treatments, at least for line and asymmetric. There is this one place where circle just starts off very high. But those initial rounds, the initial couple of rounds, there are no statistical differences.
Okay.
Fine.
Yeah, and you're muted.
Yeah. So if there are no further questions, then we'll end here. So we especially thank people coming from the AP regions. It's well past midnight. So let's thank the speakers and the discussants for a very nice session. So we'll come back next week. Thank you.
Thanks to the organizer.
Yeah,
Thank you
thanks.
so much for organizing this.
All right.